Here we go. We have a question: maximum circular subarray sum. So you have given an array of integer in a circular fashion, and we need to find the maximum subarray sum that we can get if we assume the array to be circular. So suppose we have this array, and in this the maximum subarray sum is 12, then 8 minus 8, 9 minus 9, then 10. So we have this circular subarray and we need to find the summation. So the maximum answer that we can get is 22, and in this the maximum answer that we can get is starting from this index till this index, and in this the maximum subarray sum that we can get is starting from this index and ending at this index. So we can assume the array is circular. So let's try to build the approach. In this I have this test case, and the maximum answer that we can get is this, is this, and this. So the maximum answer is this. So we have to assume the array is circular. So for this, let's try to simplify our uh, problem. Suppose in this the array is not circular, and we have to find out the the maximum subarray sum. So either the answer can be this, the answer can be this. So we have to find the maximum subarray sum, the maximum subarray sum. So what is the maximum subarray sum? Either this or this, and we have to use cadence algorithm. Cadence algorithm. So instead of this, what if we have to find the minimum subarray sum? Same cadence algorithm we can use. And what is the minimum subarray sum? The minimum subarray sum is this. This is our minimum subarray sum. The answer is minus 20. This is the minimum subarray sum. So if we subtract this value from the total value, if we subtract this value from the total value, we have circular subarray sum. So either the answer is the maximum subarray sum or the circular subarray sum. So let's uh, let's give it let's give it a walkthrough what I want to convey. So we have two variables. We need to find two things. First is the maximum subarray sum and second is the minimum subarray sum. So for maximum subarray sum, we take current max, initial value is 0, and answer max. It contains maximum subarray sum, and here we need to find minimum subarray sum, and here also we have current, min, initial value is 0, and we have answer min, so we have plus infinity, and here we have minus infinity. So first we have this value, we store this value here and here. So what we got 2, and we got 2, 2 and 2. So we have to update our answer. What is the maximum subarray sum till now? Till now we have 2, and what is the minimum subarray sum? It is still this value. It is no, it is not this value. Minimum value is 2. 2. Then let's move ahead. We have 3, so we'll add 3. We got 5. We got 5. We add 3. We got 5. Or either we got 5 or we what we'll do is either we will consider this value as a separate value or we add this value here, because we want our answer till here. We want our answer till here. So the code is look like this. Current max will be maximum of ith value plus already stored value, means current max, or we take the value as separate, and current min code will look like this. Min between ith value plus already stored value, current min, or we take value as a separate. We take value separately. So we have these two things. So either we can take these three as a separate or we can add it here. So if we add it here, we got 5, and taking separately will benefit us. So we take separate. And let's move ahead. We got 9, so we have to 9 add 9 here. We got 14. The maximum value till now is 14. Either we can take 9 as separate or we can addition 9 to this value. So taking 9 will benefit us, so we take 9. But the minimum answer till now, the minimum subarray sum till now is the minimum subarray sum, and the maximum subarray sum till now is this 14. Then we got -7. So that's here the interesting thing. So we have -7. So we have to add -7 here. We got 7, and till now the maximum subarray sum will stay as 14. Then we either add -7 to this value or we can take -7 as separate. So we take -7 as separate and our answer will change. Our answer will be -7. So till now the minimum subarray sum is -7 and the maximum subarray sum is 14. The maximum subarray sum is 14. Now let's move ahead. We got -13. So either we can take -13 as separate value or we can add -13 this value. So what we got is -6, and answer will not change. Either we can take -13 as separate or we can add -13 here. So we got -20, and here we got -20. So this is our minimum subarray sum. Then we got 2, so we got -4. Either we can take 2 or we can addition 2 here. So we got 18, -18, and answer will not change. Then we got 9. So 9 added here. Either we can add 9 or we can take 9 as separate. Then we got 2. So we got 2 or we got 2. We got this. So after iterating this, we have two values. We have two things. So one is this, which is 17, which is 14. So one is this maximum subarray sum. So this is our maximum subarray sum, and the minimum subarray sum is this -20. But if we have to assume the array is circular, so we have to remove this. Then we got our circular answer. So after that, we can write here, we need to return either answer max, or we can subtract from total, but we have to subtract answer minimum. If we subtract -20, which means this value, this value, this subarray sum, we have summation from starting and from ending. So this is the answer. So let's code this. So what we got, either we have maximum positive subarray or total summation minus maximum negative subarray. We have some variables, answer max, answer mean, current max, current mean. Then we have to iterate. We have to add current value to find the summation of all the values. Then the simple cadence algorithm, current max will be the maximum value till the ith value. Either we have to add ith value to the current maximum, or we can take ith as separate value, and current maximum will be already stored value or current maximum value. And for current minimum and answer minimum, instead of max we have to write min. So here current mean, current mean, answer mean, current mean, and answer mean. And at the end we just need to return the answer. Either the value is answer maximum, or we have to subtract answer minimum from total. So let's give it a try. This is the regular or sequential array, sequential subarray, and this is the circular. So the problem is successfully submitted, but I think I I I don't think, I am pretty sure GFG have not added a particular test case. So if I run this, I added test case here, so we got wrong answer. So this test case GFG missed. So let me explain what this test case means. We have all negative values, these values. So here we have current max, which is initially 0, and we have answer max, which is minus infinity. Then we have current mean, which is 0, and we have current, not current, answer mean, which is initially plus infinity. We have minus 3, we added minus 3, then we have to take the maximum value, which is minus 3. Then here we have to add minus 3, the value will be minus 3 also. Then we move ahead, we got minus 2, so we got minus 2, we got minus 2. Here the value will be minus, not minus 2, minus 5, and we got minus 5. Then we got minus 3 again, so this value will be minus 3, this value will stay same. Then we got minus 3, we got minus 8, then we got minus 8. Answer minimum is the whole subarray, is the whole array. So if answer minimum, if answer minimum is equal to total, we have to take one single value, which is the maximum answer. In this case the answer is minus 2, so we have to return answer max. So let me show you the code. So if I add this check, total is equal to answer minimum, we have to take a single value. So answer maximum stores that answer. So if I give it a run, it will give us expected answer. Yes. So if I submit this, it will just submit fine, because GFG missed this test case, edge case we can say. So let's talk about time and space complexity. In this function, the time complexity is orthorhombic, space is constant. With this, we have met the expected time and space complexity. Code is given in the description box. If you learned something new, give it a thumbs up, subscribe to this channel, and thank you all for watching.